Fractional knapsack. Fractional knapsack problem is an optimization problem that can be solved by greedy strategy. What is the aim in fractional knapsack problem? The aim is to maximize the total value of items that are placed in a knapsack. This knapsack will be having a limited capacity C, and you want to maximize the total value of items that can be placed in this knapsack. Let us understand this problem statement in detail, then it will be clear for you. You are having n items, and for each of the items you are told there is some particular weight for that item, and once you sell that item, that is complete item, you will be getting some profit P. So you are having n different items. Each item you know is of some particular weight, and if you sell that item, you will get a profit P. And what is the role of knapsack in this? You are a seller, and how do you sell items? You will take as many items as you can in this knapsack, and then carrying this knapsack, you will roam around the city. So by the, let us say, end of the day, you will be able to sell all the items that are in your knapsack, and you want to see which items should you pick into the knapsack so that you will get maximum profit at the end of the day. This is the problem statement. So here you have to understand that this n items, this number of items considering the weight of each of those items will be very large, that you can't have all the items in the knapsack. See, if you can put all the items into the knapsack, then there is no question here. Simply you can put all the items inside. Here the problem is you are not having enough capacity in the knapsack to insert all items. That is why you are having to make a choice of which items should you pick so that you get maximum profit. And one more thing, what is fractional here? It is called fractional knapsack because in case you want to take only part of an item in order to increase the profit, you are allowed to take a fraction of the item instead of taking the whole item. This is why it is called fractional knapsack problem. Let us see what is the greedy approach we can use for this, and by using the greedy approach, what are the steps to be followed, right? So the greedy approach is this. First of all, you have to find the profit by weight ratio of all these items. That is, you are given total weight of items and you are given profit of all those items. You want to find the ratio of profit divided by weight. What will this give you? This will give you the profit per unit weight. Once you get the profit per unit weight, you can compare the profits of different items, P1, P2, etc. Why is this? Because initially, let us say some item is having a profit P1, which is greater than profit P2, but you cannot directly select this item because maybe the weight of the item P1, which is giving profit P1, W1, this may be much greater than weight of the item which is giving profit P2. So in this case, even though P2 is less, it will be beneficial for you in order to take P2 over P1 because P2 is weighing much lesser, and because of that you can take even more items in the knapsack if you are choosing P2. So in order to find which is more valuable, you want to know profit by weight ratio, because this will tell you per unit weight what is the profit provided by each item. This is how you can compare profits. So whatever ratio you get here, you can directly compare these profit ratios and say item A is better than item B. That is profit wise better than item B. So once you get this profit by weight ratio, what should you do? You should greedily choose that item which is having maximum profit by weight ratio, because this item, even if you take 1 kilogram, it will give you higher profit compared to any other item. This is the greedy approach we are going to follow. So what are the total steps that we have to take here? The first step is you have to calculate profit by weight ratio. So let us say you calculated for each of the item, you calculated profit by weight ratio. So at this point, you know for each item what is the profit per unit weight. What is the second step? Second step is you have to sort all the items by this ratio. So sort all the items by the ratio. Ratio is profit by weight ratio. Once you have this sorted list, what should you do? You should start picking items greedily. So how do you pick items greedily? Check into the first item, and then if the weight of this item is lesser than the remaining capacity of the knapsack, in that case you can directly select this item. There is nothing to be thought about. If the weight of this item, which is having maximum profit, that is maximum profit by weight ratio, is lesser than the capacity of the bag, that means this item can completely go into the bag. So you can confidently take it. Otherwise, in case the capacity of the bag is smaller than the weight of this item, in this case, you have to consider taking only a fraction of this item. So this is where the tricky part comes in. You have to take only the fraction of the item which will be good enough to go into the remaining capacity of the bag. So this is the fractional knapsack problem. So till the point you face a situation where complete item cannot go into the knapsack, you can keep inserting items greedily into the knapsack. Greedily means from this sorted list, you can simply select each item into the knapsack. One more thing, that this sorting is in descending order, not in ascending order, okay? Because you want highest profit by ratio to be selected first. So this sorting is to be done in descending order. So once you have this sorted list, you can greedily pick each of the items. And when should you stop? Whenever your capacity is 0, or if you see an item which is having weight larger than the capacity, then you should take a fraction of that item, and that should be the last item you can put it. In short, you don't have to take fraction of multiple items. At max, there will only be one item for which you are taking fraction, right? So the next thing is, we told in the initial greedy algorithms lecture, that whenever you as a programmer is looking into a problem, you should consider greedy first, because that is your best approach. But there are two properties to be satisfied, which will tell you whether greedy is applicable here or if it is not applicable. So in order to clarify that, you have to see for the two properties that are to be satisfied, and let us see how those properties are satisfied in this particular case. So the first property is greedy choice property, and the second one is optimal substructure. These two properties are to be satisfied if you have to use a greedy strategy. What is greedy choice property? Greedy choice property says that you should always make locally optimal choices, but making these locally optimal choices should eventually lead you to the global optimum solution. So if this property holds, then only you can apply greedy strategy. So how does it hold here? Here, what are you doing? At each point, you are making a locally optimal choice, which is greedily choosing whichever be the item with maximum profit by weight ratio, which means you are maximizing your profit as much as possible at this point. What does that mean? In the first step, you are choosing that item which can provide you maximum profit per unit weight. This means if you continue the same strategy for all the remaining items, let us say second item, you again took whichever item has maximum profit by weight ratio. If you do this, then ultimately you are going to have global optimum or maximum profit, because you are greedily choosing each item which is having maximum profit at that moment. From the remaining items, whichever is having maximum profit, that is what you're choosing, which means you will reach a global optimum and the greedy choice property is satisfied. What about the optimal substructure here? Optimal substructure says, in order to construct the optimal solution, you should be able to break the problem into smaller sub-problems, and then solving the sub-problems should lead you to final solution. So here, if you consider the sub-problem, you are converting it into multiple sub-problems where each sub-problem is finding the best profit by weight ratio element that is remaining. So let us say you chose one particular element, which is the first element according to profit by weight ratio. What are you effectively doing here? You are decreasing this problem, or you can say you are creating a sub problem. The remaining problem is a sub problem of the original problem. That is, originally you had a problem, that is, you want to maximize the profit you can gain from this knapsack. What did you do? You chose one item into the knapsack which is having maximum profit by weight ratio, and the remaining part you have a sub problem here, and this sub problem is exactly same as your original problem. The only difference is you already made the first selection, and the remaining part is a sub problem which is exactly same as your original problem. With the remaining items you want to find maximum profit from a knapsack which is having reduced capacity. That is, capacity of first item is already taken. With the remaining capacity, whatever be the problem you were solving previously, the same sub problem you have to solve, which means here this problem can be broken into smaller parts and it follows optimal substructure property. So fractional knapsack problem follows both the greedy choice property as well as optimal substructure property, which means you can use greedy algorithm here. That is why we are using the greedy algorithm. The next thing is, what are the time and space complexities when you are using this greedy algorithm? So in the first step, what did you do? You found the ratio which is profit by weight. For each of the item, you found this profit by weight ratio. Second step is you sorted all the items according to the ratio, according to the profit by weight ratio. You sorted all the items. And what is the third step? You ran a loop, let us say for I is equal to 1 to length of array minus 1. So you went through each of the items in this sorted array, and what did you do? While picking each item, you checked whether this item's capacity, weight of this item, is it lesser than or equal to the capacity of the bag. If it is lesser than or equal to, then what did you do? You will pick that item. If it is not, then what will you do? You will take only a fraction of this item. So this is the step that you have to follow. So while doing this, first step, that is finding the ratio, profit by weight ratio, even if you are initially finding profit by weight ratio for each element separately, it will take only order of n time. And the second step is sorting. So sorting, will take order of n log n time. And after that, you're going through each element one by one, and you're doing some order of one operation here. So this should also take only order of n time, which means the greatest or maximum term is n log n, and the time complexity of this fractional knapsack algorithm is order of n log n. Okay, this is for the fractional knapsack algorithm. Next thing is space complexity. So coming to space complexity, actually you can do this in order of one space. You don't have to use any additional space. You can do this if you are not separately calculating and storing these ratios. If you want to store the ratios of all items separately before you start processing, then you may have to take order of n space right there for storing the ratios. But you have an option that if you are having a tuple array as the input, let us say in the input you have an array. This array will be having profit weight P1 W1, then P2 W2, such that there will be tuples of profit and weight. If this is the input array you are having, what can you do? You can simply write a sort function, and this sort function can do the comparison of elements based on P by W, profit by weight ratio. So you don't have to calculate all the ratios and keep it separately. While you are sorting, you can simply compare profit by weight ratio instead of comparing profit or weight. Okay. So in that case, you can do it in order of one space. You don't have to take order of n. Okay. Otherwise, if you don't implement it correctly, it may go for order of n space. So the time complexity is order of n log n, space is order of 1. let us take an example and clearly understand how fractional knapsack algorithm works. Okay, so let us say this is the knapsack we are having, which is having a complete capacity of, let us say, 100. 100 is the capacity of a knapsack. And what are we going to have? We are going to have different items. Let us say the profit and weights are uh, 50. Let us say 50 is the profit for an item of weight 10. You have another item which is having 60 as profit, but its weight is 20. Another item which is having again 60 as profit, but weight is 30. The next item is having, let us say, 120 as profit, but the weight is 40. And the next item is having 125 as profit and the weight is 50. So these are the items you are having. Let us see how you should put these items into a fractional knapsack. First thing is to find the ratios. So here I am separately finding all the ratios. Here the ratio will be profit by weight. You are having a, okay, I'll mark as profit, weight, profit, weight. So whichever is the first element, that is the profit, and the second one is the weight of the item. Okay, so this is the knapsack I'm having. What is the profit by weight ratio of the first element? It is 50 by 10, which will be 5. What is the profit by weight ratio of the second element? It is having 60 as the profit if you sell 20 units of the item. So profit per unit weight is 3. That is 60 by 20 is 3. What is the profit per unit weight of the third item? It is 60 by 30, which is 2. What is the profit by weight of the fourth item? 120 divided by 40, which is 3. And what is the profit by weight of the last item? It is 125 divided by 50, which is 2.5. So this should be 2.5. What is the next step? You have to see all these ratios and you are going to choose that item which is having maximum profit by weight ratio. So the maximum ratio here is for the first item which is having a profit by weight ratio of 5. So I told you that your knapsack is having total capacity of 100. So let us take the first item in. First item will give us, let us also take count of the profit. Okay. The profit you are getting here is 50. With the first item, you know profit is 50 and weight is 10. So if you put the first item inside, you will get a profit of 50 and weight is 10, which means your remaining capacity is 90. From 100, 10 units are gone. 90 is the remaining capacity of your knapsack. And your first item is already picked. What is the next pick that you should do? You should take next one which is having highest profit by weight ratio. So here you can see next best is 3. After 5, the next best is 3. Coming to the value 3, if you take the second element, you are having profit of 60 if you take up 20 units of weight. So 50 plus 60 will give you a total profit of 110 here. So profit is now 110 and the remaining capacity 90. From that 20 is taken up for this item, which means you have 70 remaining and you inserted 2 items into this knapsack now. Which is the third option? Again you have one more item which is having a profit by weight ratio of 3, which means it is having a profit of 120 if you use up 40 units of weight. So 120 added with 110 will give you total of 230. So when you add this third item into the knapsack, your profit becomes 230. And what about the remaining capacity of knapsack? You are going to take up 40 units of additional space. So from 70 it comes down to 30 because 40 is taken up and you have 3 items in the knapsack now. Which is the fourth item you can pick? So the third item is also picked. Fourth item to be picked is the fifth one which is having a profit by weight ratio of 2.5. So here you get a profit of 125 if you use weight of 50. But the problem here is the knapsack can hold a maximum of 30 units of weight. But this item is having a weight of 50 units, which means you have to take only a fraction of this item and you can't take the complete item. Your knapsack is already almost filled and you can't afford to take this complete item into the knapsack. What will you do? You'll take a fraction of this item. How much of this item? 30 units is what knapsack can afford and 50 units is what you have. So 30 by 50 of the total profit will be a profit from this item, because you're only taking 30 by 50 of this item. You will get 125 units of profit only if you sell the complete 50 units of weight, but you are only selling 30 units of weight, which means the profit you gain from this item will be 30 by 50 into 128. So what will be 30 by 50 into 128? It is 3 by 5 of 125, not 128. 3 by 5 of 125, it is 75. So your profit will now increase by 75, which will take it to 305. And your knapsack capacity, this 30 is also depleted now, which means capacity remaining is 0. You can't insert any more elements into this knapsack. So your knapsack is completely filled now. You can't insert any more elements. So the fifth element is partially inserted, but the third element, this cannot be inserted now because you don't have any more space in knapsack. This is the fractional knapsack problem. And what is the profit that you got? It is 305. If you have a doubt, you can check out whatever be the other arrangements that you try in this knapsack. You will never be able to make a profit which is larger than 305. 305 is the maximum profit possible, and that is achieved through greedy strategy.